summarized and classified into primary pollutants and secondary pollutants. There is also another type of pollutants classified as hazardous air pollutants or toxic pollutants, but these are the major types, primary and secondary air pollutants. Since we are going to see them in details, there's no need talking much about them here. Alright, what exactly are primary pollutants? Primary pollutants are simply those pollutants that are emitted directly from their sources. That is, there is no change in the chemical composition. As they are emitted from their sources, they just pollute the environment. And these are some here. Looking at this chart, you see that about 46.2% of pollutants come from the transport sector. We now begin to talk of other stationary sources like burning of fossil fuel, as she was saying, industries contributing 15%, and then waste. The waste we even see more contributes just 2.5% of air pollutants in the atmosphere. So, like Mr. Harrison said, this is actually where, if we want to target air pollution, we should start. It's not like we are neglecting others, but we should start from where the impact is really much. Next slide. Alright, what are sources of these primary air pollutants? Can we just name them? The sources of primary air pollutants, based on what we know, of course, they are there. Can we just name them? Are you seeing? It's not really clear.
Yeah.
Oh, sorry about that. But then, looking at the definition, I think if we are all here, we should know. Can we just randomly list some of those primary sources of air pollutants? Yes? I didn't get it. Alright, yes? Yes? Where's Melissa? You confused me with French.
I'm here.
Alright, can you just maybe tell me some? I know I'm dealing with experts, that's why I'm just playing around anyhow. Some primary sources of, some sources of primary air pollutants. Alright, from cars and the rest. Alright, natural sources, you have natural sources there. You have volcanic eruption, wildfires, ocean spray, dust storm, lightning. Those are all sources of natural sources of primary pollutants. Then we have anthropogenic sources, of course, sources, human-made sources. That's where we begin to talk of industries, traffics, maybe crop residues, and many more. These are actually the sources of primary. Many others might exist, but looking at them, I don't really see the ones that are left out, except maybe other experts are going to tell me more about that. Alright, next. Alright, just look at these pictures. You have volcanic eruption, wildfires, we listed them there already. I just want you to reflect on this. Are we here? Just look at it. Do you think natural sources of pollutants are also a problem? Why not? We have just seen natural sources of air pollutants. What are some of the natural sources of air pollutants we just saw behind? What are some of the natural sources of air pollutants we just saw behind? Alright, good. So I'm now asking, do we really think that the pollutants from these sources are really a problem?
Yeah.
Okay, he don't know. Who thinks that is not a problem? Alright, everybody believes that and knows that it's a problem. Of course it's a problem. They are just sources of the same pollutants. It's not like the pollutants they emit are or behave or have different chemical or properties. So they are also a problem, of course. That was strong. I will not no one to call permanent. This period, I think Mr. Harrison can testify. Do you think the quantity of dust can be compared with any other city in Cameroon? I don't think so. Sure. Is that true? It's not possible. Alright. That's a special case. Now that rates are falling, we are happy. Next slide. Okay.
Okay, just a kind of thought, or maybe reflection. If looking at the natural sources of pollutant, like look at something like volcanic eruption. You know, you cannot control volcanic eruption. Maybe dust storm that happens in the Sahara that we are from Nigeria or in the west of Africa. Since they are natural, do you think that what can we do if they are natural?
The next slide answer that question. You look at here, I just did a little bit of comparison between natural sources and human sources, and I did that under 3 factors. That is the duration, control, and impact. The very first one, natural sources are temporal, and human sources are continuous. There is never a day you will get up and then you don't see bike men on the street there. They're hustling. But if maybe a mountain erupts now, it might take hundreds of years, maybe before it ever repeat itself. That's just the very first one. Control. Natural sources are self-controlled. Humans cannot control them. They just regulate themselves automatically. But then, human sources can be reduced, of course, with policies. Us sitting here is because we want to look at how possible we can reduce human sources. We cannot be talking of natural sources here. Since natural sources are self-regulatory, let's handle the human sources. Of course, natural sources will handle themselves. What is actually killing us? What is causing our air to be polluted every day is, of course, 92 or 99% human sources and not actually natural sources. The impact can be severe, but often short-lived. Still falls back to control. Long-term and cumulative health, environmental impact. Human sources, like we already established, is continuous. Every day, PM 2.5, 10, 1, cars are emitting it on the streets of Douala. Next slide. I don't, it's your...
Okay, it's okay.
Alright. Okay. What then are secondary sources? Secondary sources of air pollutants are simply, what then are secondary pollutants? Secondary pollutants are simply those pollutants that are formed in the atmosphere, and they are not emitted directly from any specific source. They are as a result of primary pollutants. And you see, secondary pollutants exist as combined as molecules, because it is due to some chemical reactions in the atmosphere. You have the ozone, sulfuric acid, nitric acid, PM 2.5, and what you see there. This picture actually shows it. That when cars emit it, when other natural sources here emit it, it comes, and in here you have some chemical reactions that we'll see ahead, and the result are often secondary pollutants. As we go ahead, we are going to see some simple differences between the two. Next slide. Alright, formation of secondary pollutants. Photodissociation, that's the very first one. that I decided. It's not like it's the very first one that is formed. The very first one I decided to talk on. Photodissociation of nitrogen dioxide. Photodissociation simply means that the nitrogen dioxide breaks down in the presence of UV light. When it breaks down, you have nitrogen oxide plus oxide. And that oxide picks up a molecule of oxygen and you end up with ozone. Of course, we know what it does to our environment. You have formation of acid rain, being it through sulfuric acid or nitric acid. Those are the equations there. Pans formation. That is actually the equation there. If you are interested, you look at it carefully. Particulate matters. I just took two to show how when the sulfuric acid reacts with ammonia, it gives one of those particulate matters. Even though the harmfulness of pollutant depends on various factors like concentration, duration, and the rest, secondary pollutants are more dangerous than primary pollutants. This is not to say that primary pollutants are not dangerous. We are just comparing two things. And the very first reason is because they are highly reactive and extremely more toxic than primary pollutants. And they travel long distances, much more than secondary pollutants. You can have other things. Now, how can we now regulate secondary pollutants if we cannot handle the sources directly? How can we regulate it? Who thinks there's a way? Who thinks there's a way we can regulate secondary pollutants? Yes, please, not you for now, please. All right.
From what you said earlier, you said secondary pollutants come as a result of primary pollutants.
Yeah.
So if you can try to, first of all, try to regulate primary pollutants, then automatically we are going to regulate secondary pollutants.
Marilyn, please add in a bottle of water here. I think he deserves one more. I think that is just it. Is there anything different from that? Are you thinking of something else? Because that's what I have. That's the answer I have. Maybe somebody has another answer. Different from what, or first of all, you got what he said. You got what he said?
Yes.
Alright. So, is there any other means, any other way we can regulate secondary pollutants directly rather than passing through primary pollutants? Alright, nobody is saying anything, it means there's no other way. So that is it. Next one. Oh, you mean the red color I use was not the best. Yeah? Well? Note, here we just want to establish the fact that there are actually some greenhouse gases that are not really pollutants to an extent, like water vapor. Water vapor generally we know as a greenhouse gas, right? But then it's not really a pollutant, except maybe somebody has something else. But that is what I found out. And we have other pollutants that are also greenhouse gases, like carbon dioxide, methane. We have pollutants that directly affects air quality and climate. I mean, when I talk of directly, we are talking about ozone, we are talking about soot, black carbon. When I talk of directly, it means they do not react with anything to form something that then affects the climate. They themselves affect the climate directly. You get the difference? So that is, this one is just to establish that fact. It's nothing much about that. Is just facts. That's just knowledge. All right. What do you think? Oh, okay. What do you think is the leading cause of death among Cameroonians? We have experts in that field here. Or even if not what do you think generally is really killing Cameroonians?
Malnutrition.
Wow. Malnutrition. Yeah, I think does it fall? Hunger, malnutrition, air pollution. So, at this, even if we end here now, will you really still think air pollution is not worth targeting? It's worth targeting. Alright, next slide. Now, let's just look at this. How many people die from air pollution each year? We'll start with the WHO's data. Globally, they said about 7 million people, 4.2 million were as a result of indoor air pollution, and rather 4.2 million was as a result of outdoor air pollution, and then 3.8 million as a result of indoor air pollution. When we talk of indoor, outdoor, you understand, right? Is there anybody that doesn't understand that? Alright. Then, another statistics by Institute for Health, Metric and Evaluation said globally they had 6.7 million, 4 million, 4.5 million, and then 2.3. But then, another data said they had 8.8 million. So, when you take the average of these, you see that it centers around the 7 million. So, with all this data, will you still have a doubt with the World Health data? So, it means actually over 7 million people died each year. Now, because when I was discussing, I said I spoke about the concentration. I know that I think Mr. Harrison is going to really handle this part more, but for the sake of our understanding, let's look at it. This data is from the air quality guideline, and if I should start from here, air quality guideline said particulate matter 2.5. Particulate matter 2.5. Actually, they divided it because they knew that some countries are more exposed to polluted air than others. So what they did was, after doing all the calculations, they took what will be quantified as. Is it 10? Yes, you should have air quality of 15. That's annually. But then within 24 hours, you should. Alright, it's not with me. So what I'm saying is, we want to determine the concentration of all the particulate matter in. Alright, we want to determine the concentration of all the particulate matter in air, and we know that particulate matters or pollutants generally are divided. We have many of them. That is particulate matter, where you have particulate matter 1, 2.5, but we'll be dealing with 2.5. We have nitrogen dioxide, we have carbon monoxide, and all sulfur dioxide, ozone. But all of these have different concentration in polluted air. That is to say, we can have air, a polluted air in this room, which is more of particulate matter 2.5, and a polluted air in the next room, which is more of let's say nitrogen dioxide. A particular polluted air in the next room, which is more of particulate matter 10. You understand? So all of these have various effects, though they affect the health generally. Wow, thank you so much. You can now see, right? This is actually the air quality guideline for pollutants. Particulate matter 2.5 microgram per cubic meter. If you are breathing air with air quality 5 for particulate matter 2.5, then the air is good. The air quality is good. But if you're breathing, let's say, an air with particulate matter 50, air quality guideline 15 for 2.5 per hour, rather per day, you have up to 15, then it is still good. You understand? But what the organization said, if you are living in a very polluted environment and you have what they said, the term interim targets. Interim targets are just potential targets. Like he already made mention that for you to improve on something, you should at least know what it is. So if you measure your air and discover that it has particulate matter 2.5, it has a quantity of 35 microgram per cubic meter, then it is not really the best. So it means that if you are breathing air with this quantity of particulate matter throughout the year, you are not really doing good to yourself. But if you are breathing this air with particulate matter 75 for one day, you are not actually doing good for yourself. But then they are saying that you can be managing while looking for ways to bring down this concentration. So when you are breathing air with this quantity of particulate matter inside, you should be targeting to reduce it at least to interim target 25 annually. So if your air initially had particulate matter 2.5, 35 microgram per cubic meter for maybe last year, you should be breathing it while working on reducing it to 25 annually. So if you breathe air of 35 microgram per cubic meter last year, at least this year you should be at 25. Let's exaggerate it. You should be at 25, and you continue working so that the following year maybe you should be at 15. The next you should be at 10, and then finally you will start breathing clean air. So clean air at least should have particulate matter 2.5 of 5 microgram per cubic meter. Alright, it follows, if you have understood the explanation, it follows same here. You discover that air quality with PM 2.5, a clean air has PM 2.5 of 5 microgram per cubic meter. A PM 10 for clean air, in clean air, should be at most 15. For PM 10, it follows suit for ozone 45, nitrogen dioxide 1, 10. That is actually what should happen. So if you are breathing air with air quality different from this, then you are not doing any good to yourself at all. Is the table clear now? Anybody with any doubts? Maybe because of the terms I confused some people along the line. Have you understood, like, because you should understand this at least? Yes.
I have a worry here.
Wait.
For the presentation. Under pollutants.
Yes.
So there are many pollutants that are taken into consideration.
Alright.
Their concentration.
Air itself, polluted air itself can have all of these pollutants inside. You understand? But when you're measuring, each of them will have different concentration. It's like you take maybe water and kerosene, maybe and small kg, put all of them together. You can take maybe a liter of water, you take half liter of kerosene, you take maybe 0.25 liters of kg, you put. How many components do you have? You have 3 components, right? You have water, you have kg, and you have kerosene. You understand? All of various quantity. So, in a polluted air, it's possible that you can have PM 2.5, you can have PM 10, you can have ozone, you can have nitrogen dioxide, you can have others. But now, at what quantity is each of these pollutants? That's what we are looking at. So in a very, very polluted, polluted air, you can have PM 2.5 of 35 microgram per cubic meter. You can have PM 10 of 70, still in that same air, microgram, ozone of 100. So this one now, you see, annually here, you see daily here. So it means that the average air you breathe throughout the year had this quantity of PM 2.5. Do you understand? Throughout that year. So if you are breathing this type of air, then you are breathing polluted air. But then if you understand that you are here, you can start fighting. So that, because the lesser this value, the more, the cleaner the air. The higher the value, the more polluted the air becomes. So that's why WHO standard says that for good air, you should have PM 2.5 of 5 micrograms per cubic meter annually. Do you get it? Maybe when he comes out, he's going to throw more light.
Okay, let me just say something, because I understood that we're supposed to talk about these standards and all these things. And even the unit of you're saying that this microgram per meter cube, you have never understood what it is, actually. Microgram per meter cube simply means that in a cubic meter of air, this quantity of, for example, if you have 5 microgram per meter cube of particulate matter 10, it means that in a cubic meter of air, so you have a cubic meter that contains air, 5 microgram, the maximum amount of particulate matter that is supposed to be there is 5 microgram. And you know, 5 microgram is 10 to the minus 6 gram, which is 10 to the minus 9 kilogram. So you can imagine how small that is. So what he's trying to say is that this is air quality guideline by WHO. And they have already done epidemiological studies, the health impacts of the certain quantity of pollutant on the human health. And I've seen that the maximum quantity, maximum quantity that a human should be able to inhale within a certain period and be fine and not have a problem, it's 5 microgram per cubic meter annually. So in the course of the whole year, the maximum number of particulate matter that you should be able to inhale and be healthy is 5 microgram per cubic meter. That is what it actually means. And then this interim target, he has explained very well. It means that, for example, countries that are developing, that are industrializing, they need to take action to reduce annual particulate matter. But they are saying that while you are targeting this, you can start from 35 microgram per cubic meter. You take action and you continuously reduce. It means that it's a space of development. Because it's very difficult to come to this. Very few countries even meet this. But this is the safe limit. 24 hours, for example, you see this 24 hours is 15. It means that in a 24-hour period, the maximum amount of particulate matter 2.5 that you can inhale should be 15. That's a safe limit. Above that, you're breathing on empty air, which affects every system in your body. Anyway, we'll get to maybe talking to some of those terms, and then the standards and the guidelines, then we'll see it. Yeah.
You know, while you were doing the presentation, I was trying to connect it to the NDCs.
Yeah.
So, emission guidelines, maybe these are the things that constitute carbon emissions. So, getting the emissions at that level is also helping very much in climate action.
Yeah, is that, you know, like for example, the sector air pollution, it's an air quality, is not an independent sector. Because what are the sources of those emissions? We saw it on the graph that a major sector is the transportation sector. And if you look at the NDC of Cameroon, there's a goal on the transportation sector. The government wants to reduce emission in the transport sector to a certain level. That's why there's even a policy on the importation of electric, yes, a policy on electric vehicles. That's one of the goals that the government has taken. But in that way, they are taking it, those actions will lead us to reduce this amount of pollution. You get it right? So maybe continue to solve that.
All right, the very first studies that was ever done on a particular matter in Cameroon was done in these three towns: Bafoussam, Bamenda, and Yaoundé. And these were the concentration of PM 2.5 they had. This study was done in 2014 by Climate and Clean Air Coalition. They said in Bafoussam they had a concentration of 67 plus or minus simply means it can be more or less 14 microgram annually. So this was the quantity or the concentration of PM 2.5 in the air that the Bafoussam people were breathing in 2014. Follow suit for Bamenda and then Yaoundé.
So maybe we go now to the guidelines and look at the thing. Look at annual 2 PM 2.5.
Yes.
So you see that the air quality guideline says 5. And then
if you look at the first incident says 35.
Let's look at the target. Let's look actually, because this is the target. This is okay. The first interim says 35, right? But the goal is to get to 5.
Right.
But this is actually what is in the guideline. So the goal is to get to 5. Now if you look at this Bafoussam, so that's 5 times more than, that's 7 times more than the target, the air quality guideline of the WHO. So people, I think Douala should be here also. Douala should be 7 or 10 times. Okay. So this is Bafoussam, right? See, 60 plus or minus, this is the major error. And Bamenda, 132 compared to 5. We're trying to get to 5. And then in Bamenda is 132. And maybe Douala will be like 600. Bamenda is 132. If everyone is reasoning with us, so why do you get the reason why Bamenda is this high? It will be land use change or something? Yeah, okay. I also depend on the, alright. So, because when they say annually, this is what they do. When they're doing this study, annually they take 20, like, the first one start with hourly. So they collect the concentration every hour. Then they get the 24-hour average. They take the average every month. Then they use the average every month to get a 12-month period. That's when they come about with this annual concentration of 67. Since they have done it hourly, done it daily, done it monthly, and then taking the average for 12 months gives you this 67 per year annually.
Alright, let's shift to this.
Okay, this one now.
Yes. Alright. This was done by Global State of Clean Air. Yes, 2010 to 2020. And then here, when you look at it, bring it down to it. This is average for country, global average, World Health Interim 1, and World Health Guideline. So you look at the column. That for our country, the average was 40, still far above. Still far above. That was from 2010 right up to 2030. And there was an increase. It means that from the previous year, at least it was even better. But there was an increase of how many percent? 3%. It means it's getting worse as we go, as the years goes by. The air is becoming polluted. Next slide. All right, I think humanity is like this, just about okay, it still talks about. We are now actually looking at the leading cause of death in Cameroon itself, and the first A there is the top causes of death in females, and B here top causes of death in male. Can we see at least? Even those who go who's wow, that's good. Alright. Top causes of death in females. Death per 100,000 population, that is in 2021 in females, and this one is in male. Look at the first two in females. Lower respiratory infection, that is 64.6 death in 100,000 in that year. Next, stroke with 52. Look at here in male, 81, and then next COVID. But then now that COVID is not, you can still just reverse it. Anyway, I'm not saying that you reverse. We'll look at the current data. The first two that we directly related to what? Air quality. So this is actually our own situation. This is Cameroon's data in 2021. So it's not even malaria, though we think it's malaria. It's not really even malaria. And just let's look at this data. Okay, that is it. So it means that because all diseases affiliated to air quality, I think all of them are known. So only that sector alone contributes 35.7% of deaths that occur in 2021. So only that particular sector. Can you imagine what we are? And now I want us to just look at this. Have you noticed any changes in weather patterns that could be linked to air pollution or air pollutants? Who have noticed anything? Any changes in weather pattern that could be linked to air pollution? If you have noticed anything, just let me know. Nobody have noticed any change in the weather pattern that would be linked to air pollutants? Yes?
That is 7th image.
1, 2, 3, 4, 5, 6, 7.
Yes.
This one.
I think it will be due to an increase in temperature.
Alright. Okay, noted. Who else? Who else? Tap. Can you just tap? Mommy. Alright. It's okay. I just wanted to call her back. Alright. Because you tap her now, have you noticed any? No, not you.
There's a hand that way.
Okay, there's a hand that way. Yes?
Okay, the Wi-Fi.
The Wi-Fi.
because of climate change, global warming, the temperature, the average temperature of the earth is rising. So this cause the rising temperature that can maybe cause drought, and also just a small spark in the environment can cause wildfires. We don't really have it here, but I think that in America and Australia they experience a lot of wildfires.
Thank you so much. Now I want to ask, how did you know that it was linked to air pollutant?
The question still me.
How did you know? Because the question is, just bring it down. Yes. Look at the question. Have you noticed any changes in weather patterns that could be linked to air pollutant?
Yes. So,
yeah, and you said this, right?
no, I said wildfire.
Okay, you said wildfire.
Yes.
Now I want to ask you, how did you know that the cause was, the same question goes to you. How did you know that it was as a result of air pollutant?
So, I think that one of the air pollutants that we have is ozone. And the ozone layer it protects the Earth's atmosphere from sunlight. So, with the depletion of the ozone layer, this increases the temperature on the Earth's atmosphere. So, this can lead to wildfire. So, that's my observation too.
Greenhouse gases can also cause that. So this one was just a question that would cause you to think. I don't know if you've forgotten what is there. All of these things are caused by maybe greenhouse gas emission, and some greenhouse gases are pollutants. So there is nothing that is specifically linked to air pollutant, because you cannot actually say that this one was as a result of this air pollutant that maybe is causing this particular climate change. I don't know if you've gotten the point. So this question is no. The answer to this is no. Because you cannot pinpoint. Even if maybe there is drought, yes, it's as a result of the accumulation of greenhouse gases in the atmosphere. And some greenhouse gases are pollutants, true. But can you say that this particular one that causes this drought is as a result of this greenhouse gas that is also a pollutant? Anyway, it's okay, thank you. Next slide. Alright, environmental impact. We've actually looked at the health impact. Now let's look at environmental impact. The very first one is acid rain. The formation of acid rain that results to leaching. When acid rain falls, it reacts with essential minerals in the soil, like magnesium, calcium. Of course, they exist as carbonate. And when that takes place, it washes away these chemicals from the soil, rendering them not fertile. And then also washing these heavy metals to our rivers around. And when they get to our rivers, even with the acidic rain, it increases the pH of our water system. And when the pH of our water bodies are increased, of course, what happens? It affects their aquatic life. So you see that if acid rain falls here, it's going to affect our food security, because when soil becomes infertile, our crops will not do well, because it's even going to kill the microorganisms that are living in the soil. And these heavy metals that will be broken down will be washed up with rain runoff to streams, changing the water pH. And the moment the pH increased, you begin to have situations like fish die, and yes, and even in forest, when plants lack these very important minerals, you will see a change in color because they will not have what it takes for them to be healthy. You see maybe a forest just become yellow because of lack of chemicals. You see that is actually the equation. That is the equation, and this is the way your forest will become as a result of acid rain. And these hydrogen ion will be washed into lakes. And when they are washed into lakes together with the heavy metals, next slide, this is what you will see. And just imagine that all our fish and other aquatic life die as a result of the high pH. What will happen to us? What will happen to us? So that one is very, very, it's not good. Next slide. How it affects our climate directly. Like we already established, black carbon, ozone, hydrofluorocarbons, they directly affect our climates. Why? Because they have a very high global warming potential. Although they remain in the atmosphere for a very short while compared to carbon dioxide, but then they hit the environment at a faster rate. When they talk of global warming potential, they are just talking, they just refer to the ability of that particular greenhouse gas to heat up the environment. I think methane, is it methane? Methane have a global warming potential of, is it 28 to about 30 something? That is to say that if a kilogram of carbon dioxide can take the temperature of this room from, let's say, 0 to 1, then a kilogram of methane will take it to, that is 0 to 1 degrees, then a kilogram of methane will be able to take it from 0 to about maybe 28 or 32, I think thereabout degrees Celsius. But then carbon dioxide will remain in the atmosphere for a very long period of time. But methane, I think, has just a few days or I think so. So it has a very short life in the atmosphere, but with a higher warming potential. Nitrogen dioxide, same. Ozone, same. So that is how these superpollutants affect the environment directly. Reducing them can slow climate change quickly. How? Since they have a greater global warming potential, reducing them will actually reduce our temperature easier. You see, that is just a picture showing what will happen next. Next slide. All right. More on our reality. We are running up. A report from State of Global Air Quality, State of Global Air in 2019 says that over 13,000 people in Cameroon died from air pollution-related diseases. Over 13,000. Just look at something. Mark this word, 13,000 air pollution. And then in 2021, Biomed Central published another article, and they said that household air pollution alone caused approximately 11,400 premature deaths in Cameroon. Have you noticed something? Up here, they said air pollution caused 13,000 deaths. And then down here in 2021, this data was 2017. 13,000 people died from air pollution in Cameroon. But then in 2021, household air pollution, that is indoor air pollution, right, killed about 11,400 people. Who have noticed something? Sorry?
The prevalence, the number of deaths has increased.
Really? I think 30,000 is more than 11,000.
But the thing is that it is 18,000.
That's exactly what I wanted you to see. And I want to use that to establish the fact that the case is worsening. Because if this number can die as a result of indoor alone, then what of those that actually was as a result of outdoor? You see that from 2017, we had 13,000 people. Then in 2021, maybe we'll have 19,000 or 18,000, I don't know. But maybe looking at the data. Alright. This was actually another study reporting this average concentration of, yeah, we saw that already. Then, this is the most recent data specifically about the Douala. I think it should be because it was published in March this year. Are we just in March?
No.
So I think this is the most recent data. That is what he said. He said PM 2.5 is between 44 to 20,000, 210 microgram per cubic meter, and then PM10 50 to 240 microgram per cubic meter. Around his studies was around these two places, Pure 3 and Pure 5. That's Carrefour, Nogoti, and Carrefour PK14 there. Okay. I told you my face. Alright. QS5, this was his conclusion. He said in that Carrefour, the high concentration are actually caused by the phenomenon of resuspension brought on by the presence of unpaved roads. When he mention of resuspension, he was talking about dust that will rise, pollute, fall, rise again, and then keep doing the same thing. And then around Nogoti, the high concentration is directly as a result of traffic, that is transport. But it's not like what this one, transport does not affect him. It was just from his studies, he saw that that particular area, the principal cause at that time is as a result of this. Do you get that? Next slide.
Was it annual or?
Yes, it was annual because he started his studies, I think, when it was published. Alright. Cyril Mezua in 2017, he also did another studies. Remember, we are doing some scientific review because, like he said, without data, we don't really understand where we are. He said carbon monoxide levels increased by a factor of 18 for a period of 2002 to 2015, with an increase of 65% in two-wheelers. Two-wheelers are bikes, and 31% in cars. So he estimated that by 2035, bikes are expected 533% and car owners by 146%. So with what is already existing, if we actually experience this increase with business as usual, how will it become? Alright, these two-wheelers alone are up to 78% responsible for poor urban air quality. That was according to his research. And I think we have reviewed enough. And this guy, he just concluded that the traffic situation, the aging of motorcycles, and the nature of the fuel revealed their influences on the emission of pollution by motorcyclists. So he is simply saying that the main source of air pollutant in Douala is actually the transport sector. That is just what he said in essence. Alright, now that's just it. Vehicular emission, the city dance. So this one is nothing short of repeating that the transport sector is leading, followed by the industry, and maybe we can begin to talk of waste. Remember, we are talking about Douala. So what can we do? That is actually the question. What can we do? What can we do is a question that I'm rounding off with. Begin to think, begin to answer that question within yourself. Clean air is actually not a privilege, but it is our right. So, what can we do? Thank you so much for listening and contributing. But then we are just going to use another 2 minutes, just 2 minutes, right? Yeah. If you have a question, a contribution, a doubt, anything, within these 2 minutes, please. All right. Okay.
Thank you very much for your presentation. It's very resourceful and definitely has been pointed on the many difficulties and problems that people face definitely, which is not, they are not really aware of what's going on. Air pollution actually, as the statistics present, the statistics presented by 2013 and 17 respectively, something shows that it's claiming the lives of so many people. But I'll come back to the last phrase that you ended the presentation with. What can we do? I always believe on the solution-based issues than probably just presenting the issues. Now, it is somehow difficult or disheartening that up to around 2025 that we don't have any particular convention signed by the Cameroon government targeting pollution individually. They have signed so many protocols and so many conventions like the Kyoto Protocol, but all of them based mostly on climate change. I don't think there is any that talks about individually about pollution. And if we get statistics of people dying, 11,000, 13,000 or whatsoever dying, and the state does not have anything that has to do with this, then definitely it's a major issue that we should think about. And here I'll permit me use the word we. Let's not say the state, let's use we. As he has presented, what are we doing? I think it's a very key factor that we have to get to. Something should be done about pollution. What are we doing? States started signing about 1987 when the Montreal Protocol was signed to fight against pollution. But a state as ours, we don't have any. So probably I think the rest of the country is still at risk. No matter all the statistics are being presented, probably they don't have any impact on the country, because we don't have any particular convention talking about fighting against pollution. So definitely we need to do something probably in order to curb all these difficulties that we have. Thank you.
Thank you so much for that.
Yes, comment.
Yeah.
Thank you very much for the presentation. Based on the statistics there is enough evidence for if there is a policy, the policy can really be set on high, because there are a lot of policies, but the policy needs a lot of vital evidence to push it up that it will remain at the table of the stakeholders. It's very enriching, and I believe all of us here we are becoming advocates of air pollution. Start speaking high and presenting it on policy tables. I'm a policy student and I'm interested in the evidence, so I can.
Thank you so
really
much.
Right on it. Thank you.
Thank you so much. Thank you so much. So that we should not take a lot of time. Maybe if we have any question.